Okay, so in the last presentation we talked about one-to-one functions. We're going to see how this relates to something that we call inverse functions. So the first thing is, inverse functions have a special notation. We're going to use something that looks like an exponent of -1. This is not 1 over f of x, this is just a notation saying that this is an inverse function. So our notation will be f to the -1 of x. So what are inverse functions? We can think about inverse as being the opposite of a function. What we're going to do is we are going to switch things around. So x's become y's and y's become x's. So that means that the domain becomes the range and the range becomes the domain. The last thing that we're going to see in this section is that the graphs are symmetric about the line y equals x. So to find an inverse function, what we're going to do is replace f of x with y, because remember that's what f of x means, is that's another way to write y. We are going to interchange our x and our y variables. And then in the new equation, we want to solve for y. We're going to replace y with f inverse of x. Okay, so the first thing that we're going to do is we're going to go ahead and find the inverse function. So my first step is I want to replace f of x with y. We get y equals x plus 2. I'm going to switch my x and my y variables, so I'm going to rewrite this as x equals y plus 2. And then I want to solve for y. So I'm going to subtract 2 from both sides. We get x minus 2 equals y. And now I want to replace my y with f inverse of x. So f inverse of x is equal to x minus 2. Okay, so now let's go ahead and graph both of these equations. So for the first one, we have f of x equals x plus 2. I'm going to go ahead and graph using slope and y-intercept. My y-intercept is 2. My slope is 1. And I'm just going to go ahead and put a couple points here so that we can go ahead and see what this looks like. Okay, I don't think it's going to get any better than that. Okay, let's go ahead and graph x minus 2. We have a y-intercept of -2. We also have a slope of 1. So when we graph it, we get something that looks like this. Okay, I'm going to go ahead and label some points so that we can see kind of what we're working with here. So we have -2, 0. We have -1, 1. And we have 0, 2. We also have a point 1, 3. If we look, this is our f of x graph. If we look at our f inverse graph, let's see what points we have there. We have 0, -2. We have the point 1, -1. We have the point 2, 0. and we have the point 3, 1. So notice that these kind of pair up. And all we've done is we have flipped our x and our y's. Another thing that we want to look at is we want to look at the line y equals x. So line y equals x has a slope of 1, and it goes through the origin. If you notice here, it is symmetric about this line. All right, let's go ahead and look at some other examples. Let's look at f of x equals 2x minus 4. Let's start by finding the inverse function. So I'm going to replace f of x with y. I'm going to go ahead and interchange my variables. So we get x equals 2y minus 4. And I want to solve for y, so I'm going to add 4 to both sides. We get x plus 4 equals 2y. And then I want to divide each term by 2. So the first one, I'm going to rewrite it as 1/2 x so that we can see what our slope is, plus 2 equals y. So that is my last step is I want to replace y with f inverse. So we get f inverse of x equals 1/2 x plus 2. All right, so let's go ahead and graph both of these equations. Okay, so if we go ahead and graph this, we have 2x minus 4. That gives me a y-intercept of 0, -4. My slope tells me to go up 2 over 1. We should get something that looks like this. And we draw our line. All right, if we graph y equals 1/2 x plus 2, we start off at a y-intercept of 0, 2. We're going to go up 1 over 2. Up 1 over 2. And if we draw our line, if you want, you can put a couple other points there. We should also have these ones here. We should get a graph that looks like this. Okay, so if we go ahead and remember that we also want the line y equals x. And sorry, I'm not capable of drawing straighter lines on my iPad. But we should get something that looks like this. Okay, let's go ahead and label our points. If we look here, we have -4, 0. We have -2, 1, 0, 2. Two, 3, and 4, 4. That's going to be my f of x. On my f inverse of x, let's see what points we have. we have 0, -4, 1, -2, 2, 0, 3, 2, and 4, 4. So if you notice, we do have that correspondence again. We have our x's and our y's flip. Okay, let's do one more linear example before we look at some others. So the last one that I want to look at for linear equations is g of x equals -3/2 x plus 6. So let's go ahead and find our linear function. Let's go ahead and find our inverse function first. The first thing that I want to do is I want to go ahead and replace g of x with y. I'm going to switch my variables. So we get x equals -3/2 y plus 6. I'm going to go ahead and subtract 6 from both sides. We get x minus 6 equals -3/2 y. And now if I go ahead and, what can we do? We can go ahead and multiply by 2 to get rid of the 2 in the denominator. We can distribute it on the left side, so we get 2x minus 12 equals -3y. And then I can divide by -3 to each term. So we get -2/3 x plus 4 equals y. So my inverse function is -2/3 x plus 4. Okay, so let's go ahead and graph these. So g of x, if we graph that one first, we have a y-intercept of 6, and my slope tells me to go down 3 and over 2. I'm going to do that a couple times just to get a good shape here. We should have a line that looks like this. So now I just want to go ahead and connect the dots. My second one is -2/3 x plus 4. So we're going to start with a y-intercept of 0, 4. This tells me to go down 2 and over 3. And if I connect my dots here, we get something that looks like this. I also want my line y equals x. And now let's go ahead and look at our points. So for our first equation, f of x, what are some points that are on this line? Well, we have 0, 6. We have 2, 3. And 4, 0. And sorry, that's not f of x, that is g of x. For our g inverse of x, what do we have here? We have 0, 4, 3, 2, and 6, 0. So if we look at these again, we see that what we have is 0, 6 and 6, 0. We have 2, 3 and 3, 2. And we have 0, 4 and 4, 0. So note that all we do is we change our points. Okay, so that takes care of our linear examples, so let's go ahead and look at some other ones that we can do. Let's start with f of x equals x cubed plus 2. So the first thing that we want to do is find our inverse function. I'm going to go ahead and replace f of x with y. I'm going to go ahead and switch my x and my y, so we get x equals y cubed plus 2. I can subtract 2 from both sides. We get x minus 2 equals y cubed. And then remember that in order to get rid of a cube, we want to use cube roots. So we get the cube root of x minus 2 equals y. Last step, we want to go ahead and put this back in function notation. This is the inverse function. So I'm going to have f to the negative 1 of x equals the cube root of x plus 2. Okay, so now to graph this, because we don't have a lot of experience with cubic functions and cube root functions, I'm going to go ahead and make a table. I'm going to work with the values negative 1, 0, and 1, and plug them into my original function. So if we plug it into, let's work with negative 1s first. We get negative 1 cubed is negative 1, plus 2 is 1. If we plug in 0, we get 0 cubed is 0, plus 2 is 2. And the last one we have is 1 cubed plus 2 is equal to 1 plus 2 is equal to 3. Now the last thing to keep in mind, these are 3 points. It doesn't quite give us the best shape, but we're going to work with it. Just remember that cubic functions have kind of a snake-like shape to them. Now I'm going to use this to help me with my f inverse. Instead of creating another table and trying to find values to plug in, I'm going to cheat, and I'm going to use this definition of the fact that it is a inverse function. So I'm going to take all of my y values from my previous table and make them x values. I'm going to take all of my x values from my previous table and make them y values. And so now we've got another table. We have enough in order to graph this. Okay, so let's go ahead and graph f of x. F of x, we have negative 1, 1, 0, 2, and 1, 3. And again, just remember this is not linear. This is a cubic, and so it's going to have a shape that looks something like this. All right, for my f inverse of x, we're going to have 1, -1, 2, 0, and 3, 1. If we go ahead and graph this, it's going to look something like this. The last thing we want is we want our line y equals x. And so if you drew this correctly, you should see that it is symmetric about the line y equals x. You should see kind of a mirror image there. Okay, let's try one more cubic function. Let's try g of x equals x minus 4 cubed. So let's go ahead and start by finding the inverse function. The first thing I'm going to do is replace g of x with y. I'm going to interchange my variables. And then I want to solve for y. So my first step is I want to take the cube root of both sides. We get the cube root of x equals y minus 4. And then I'm going to add 4 to both sides. So we get the cube root of x plus 4 equals y. So my inverse function is g inverse of x equals the cube root of x minus 4. Okay, so let's go ahead and make some tables and see what we can do here. So I'm going to work with x and f of x. And I'm going to work with the values of 3, 4, and 5. Anything bigger than this or smaller than this is going to be a little bit hard to graph. Okay, so let's go ahead and see what happens if we go ahead and graph this. If we plug in 3, we get 3 minus 4 cubed. 3 minus 4 is -1. Cubed is -1, so we get -1. All right, if we plug in 4, we get 4 minus 4 is 0. Cubed is still 0. And finally, 5 minus 4 cubed, we get 5 minus 4 is 1. Cubed is 1. Okay, for my inverse function, that should be a g. I'm going to switch my columns. So we get x is -1, 0, and 1. And my y values are going to be 3, 4, and 5. So just whatever was x's becomes your y's, whatever was your y's becomes your x's. Okay, so now if we go ahead and graph this, we're going to go ahead and graph our first one. We have 3, -1, 4, 0, and 5, 1. If I graph that, I do want it to be a snake shape, so it'll look something like this. If we go ahead and graph our inverse function, we get -1, 3, 0, 4, and 1, 5. And this is going to be kind of a sideways snake shape. We can also draw our line y equals x. And it's not fantastic, but you can kind of see where it is symmetric about this line. Okay, so that takes care of graphing, and that takes care of our discussion involving inverse functions. The next section that we're going to look at is exponential functions. So come back and we'll see it again.